HANA architecture. What is the architecture of SAP HANA?
So, SAP HANA is a columnar database, and it is an in-memory database. And massively parallel processing. The main importance of SAP HANA is columnar database, and it's an in-memory database and massively parallel processing. An in-memory database is one that stores data in RAM rather than the hard disk. RAM access is very fast, and any data present is referred to as data in memory. HANA stores table records in the sequence of columns. The entries of a column is stored in contiguous memory locations. The advantage of columnar data storage is the faster data access. Which allows faster data access and efficient compression. In a column store, data is already partitioned, which means the operations on different columns can easily be processed in parallel. Its multiple columns need to be searched or aggregated. Then each of these operations can be assigned to a different process of a core. The SAP HANA database was developed in Java and C++, and it is designed to run on the SUSE Linux operating system. Now we will see The key architecture of SAP HANA. So we have application like client applications, SAP HANA can also connect via client applications, access engine, to a client application. This is helpful for obtaining our data from different locations. Currency is not recommended to attach more than one ERP for instance of SAP HANA. SAP HANA is a non-blocking database, and it also includes the components like index server and preprocessor server. And statistical server, name server. So these are the main components of SAP HANA database. Index server, preprocessor server, statistical server, and name server. SAP HANA can connect index server is the main component of SAP HANA. It contains the actual data and the engines to process the data. And preprocessor server index server utilizes the preprocessor server to analyze and to extract the data from text and called via the and statistical server to analyze and present status, performance, and from all SAP HANA database components as well as the underlying hardware components itself. In name server, the topology of SAP HANA database is over here. In a multi-server, in the attributed landscape, the name server will record which data is on which server to decrease associated with pre-indexing. Now let me show you in the system. Click on SAP HANA Studio. Right click on System. Click on Configuration and Monitoring. Click on Open Administration. Here we can see overview of the system. To see all the components of SAP HANA database, to see different services for these index server, name server, preprocessor server, and access engine. Here we see index server, which is the main component of SAP HANA. It contains all the actual data and engines to process the data. Index server process data internally whenever we send a request. Suppose you're trying to read data from, then it goes to the transaction manager. Transaction manager coordinates and controls transactions inside the index server. Once the coordination and control is done by the transaction manager, then we have something called MDX processor. Once the coordination and control is done, SQL processor is a component to query data, calculation engine, and the request goes to the here we can stop the services based on our requirement And we can also reconfigure the services. And here we can see different options to start making the services. Click on Overview. HANA stores the data. Here we see data is under Overview tab. That is the disk usage, SAP HANA, in memory, and here we can see the CPU usage. And here we can see the data volume size and the log volume size. Data volume and log volume contains the log information. Click on More Information. Here we can view complete information of data usage. That is, so here we can see the total disk size, and here we can see the total disk size. Apart from log, and HANA also has repositories, SAP HANA metadata, object like attribute views, analytic views, and calculation views. The entire metadata is stored in repository manager. Let me explain about system layer. It is used for backup and disaster recovery. In persistence layer, in CPU usage and disk usage, how much memory is used in SAP HANA, how much memory is allocated from each component, and how much is allocated for peak used memory. Click on landscape, CPU usage, disk usage, peak used memory, that is index server, name server, how, how much is allocated for the use memory, and peak use memory. All this information and all these are handled by the persistence layer. Next component is preprocessor server. Preprocessor server is mainly used for risk analysis, text analysis. Whenever we would like to go and extracting the information from text data, whenever the text search capabilities are used, we can see this preprocessor server in the landscape. Here we can see the preprocessor server, which is mainly used for text analysis. Next one is statistical server. Statistical server is mainly responsible for collecting data related to resource allocation. Like resource allocation consumption and performance of SAP HANA system. And the statistic server improves the performance of SAP HANA system. We can monitor the SAP HANA system performance under Performance tab. Here we can monitor SAP HANA system performance. Here we can see the host name and port number. And here it will handle requests. And here you can see the sessions. Subtabs allows you to monitor all the sessions in the current landscape. That you can see active and inactive sessions and their relation to the application. Whether a session is blocked, which session is blocked, the application server, database users, client host, and the number of transactions that are blocked by a blocking session. Statistics like average query runtime and the number of DML and DDL statements the operator currently is processed via active sessions. And here we can also see the number of records, which time, average query runtime, and the number of DML statements. The SAP HANA Statistics Server is mainly for monitoring the SAP HANA database. Mainly it performs the task like regular checks for physical situations, responsible for generation of alerts, and it will give regular history collection of monitoring information into the statistic schema. Here we can see the schema and the catalog. Here we can see the underscore sys activity schema. In this schema, we can see the regular history of the monitoring information. And next component is name server. It contains all the information about SAP HANA system landscape. Here in the under overview, at the regular information, we can see whether it is a distributed system or not, and the platform is which server is installed. All this information related to system landscape stored in this server. SAP HANA can be configured as the end user. Means we can have multi-node systems, but here are on the single node systems. In distributed environment, there are multiple nodes with each node which has multiple CPUs. Name server holds the structure of HANA system. It has information about all the running components, and the information is shared on all the components. We can also monitor the SAP HANA system performance in the SAP HANA cockpit. Let's open the SAP HANA cockpit. Right click on System, open SAP HANA cockpit. Enter the username and password. SAP HANA is like dashboard, which is in the visualization. Here you can monitor the used memory. In this you can see database used memory, database allocation limit. Here we can also see the CPU usage, disk usage, and go back. Here we can see the CPU usage. In the managed services, we can see database status. Here we can see different services which we have seen in the HANA Studio. The same things we can see also here. Here we can see the status is running. All the services are in running status. We can start the missing services. Memory allocated services. All this information can be stored in statistic server. Now let's see how do we size SAP HANA. Sizing of SAP HANA is mainly based on the main memory, mainly based on the main memory and disk and the CPU. Memory sizing is determined by the amount of data that is to be stored in the memory. In general, the sizing of the other components within the server is derived from the main memory size. Apart from the main memory sizing, other two important part of the sizing is CPU sizing. The data in SAP HANA is compressed. The expected compression factor is not the same for different scenarios. The main memory size is evaluated depending on the scenario. SAP HANA main memory sizing is divided into static and dynamic RAM requirements. The static main memory relates to the amount of main memory used for the holding of table data. And the static memory sizing of SAP HANA is determined by the amount of data that is to be stored in memory. And the dynamic RAM requirements. Additional main memory is required for these objects that are created dynamically when new data is loaded or queries are executed. The sizing of SAP HANA is also based on disk and CPU sizing, SAP HANA is an in-memory database but still requires to preserve database information if the system shutdowns. Either intentionally or due to the power loss, the disk size can be categorized into different layers. And the disk loss. Persistence layer is also called data volumes. Disk log is nothing but called as log volumes. CPU sizing needs to be performed to the additional sizing, memory sizing. If the active amount of users small amount of data which is expected. The CPU sizing is for sizing calculations. SAP has provided various guidelines and methods to calculate their standard ABAP reports and DB scripts and quick sizer. Standard ABAP reports use table type compression factors and provides much better accuracy of sizing results. DB script will analyze the database catalog and determines the overall database table information. For both row and column stores. Quick Sizer is a tool which is provided by SAP. In this tool, we can estimate the data size, per CPU requirements. Most of the times we use Quick Sizer. Here we can calculate the DB size and the compression factor. Standard ABAP reports detailed result as compared to DB script. When we use a column store, the system performs the encoding of data. Whatever the data is in the form of strings, the SAP HANA converts into integers. When it converts into an integer, the size of disk is 1 TB. The same data in SAP HANA is stored in memory database. It requires only 250 GB. The compression factor is usually 4. The estimated CPU requirement for database server 4, 8, 16, 32, and 64 CPU. Go back to the HANA Studio. Here expand the schema, expand tables, expand schema, expand tables, double click on tables, click on runtime information, click on columns. Here we can see the In today's session, we have seen SAP HANA architecture and how to check system performance in the HANA Studio and SAP HANA Cockpit, and SAP HANA sizing. If you want to see the assignment for today's topic, go to Dropbox Set to folder, go to Set to Assignments, open HANA Admin Assignments. Here you can see the assignment for SAP HANA for architecture. Let's open the assignment. Download all the sessions. Click on SAP HANA. Right click on H20 system. Click on Configuration and Monitoring. Click Open Administration. Here we can view different components like index server, name server, like this. I've given assignments in this topic.
Thank you all the participants to attend today's session. I'll see you in the next session. Thank you.